First activity that we're going to do today with our teacher participants explores one such real-world experience, and that is earthquakes. The group is going to be challenged to build a house that will withstand a moderate earthquake that they create. But first, they have to build their house. To do that, we provide a number of common materials to build their house of: pretzel sticks, lasagna, craft sticks, clay, styrofoam, and straws. And working in teams, they're going to be challenged to take the materials in a creative way, design a house that afterwards can be tested to withstand an earthquake. But to do that, we need a foundation for our house. Can I have one of the foundations, please? You can use cardboard for that. You can use a ceramic tile that's surplus from a local tile store. This will act as the foundation that will be the same size for everyone's home. Upon that foundation, you can take the materials, combine them in any way you'd like. You do have to have a roof on your house. It would be nice if you also had a doorway and some windows. So I'll leave that up to your creativity.
We're going to use the clay, right? Right. For glue. You want to use the pipe cleaners to do the windows? Oh, how big do we want to make it on this side? How do you want to connect these together? Do you want to have put it in between each section? Oh, okay.
So, how's it going?
It's good.
Any questions at this point?
I do have one question. When we started this, you didn't really give us any rules about how pieces had to be joined, and we do have gaps between our walls here. Do we need to do anything about that?
Well, today we won't worry about it. In the terms of a group of kids, depending on their age and their experience with using materials, you may want to tighten it up and constrain them to saying that there should be no gaps. One of the things I want to observe here is that with very little instruction, you used a variety of materials, and you even made your own tools. And part of the National Science Week activities are geared to solving problems. If I solve every problem for the student ahead of time, there's nothing left for them to solve. So one of the things you purposefully do is give them the materials with as few instructions as you can get by with for the age level, and let them come up with some questions and perhaps how to solve them. And speaking of questions, Wendy, I know there's some out in the audience.
I'm curious, Chuck, if you think giving some problem-solving time before they actually start using the materials, will that enhance this project? Did you deliberately not give them any time to talk with their partner and plan out how they're going to use some of the different materials?
I think that's a good question. Again, with youngsters, it is a good idea maybe to let them know what the materials are going to be and to have a complete period just to brainstorm. Again, this allows them to create on paper a prototype house and then test whether they can actually build what they've drawn, test the reality of that. In this case, with older students, a lot of times they come prepared with some experiences that allow them to get into it faster. Scale drawings, though, however, are a good mathematical tool to combine with this activity.
I just had a comment. I like the open-endedness of it, the fact that you didn't give them a recipe or too much structure to the activity, and it allows for a lot more creativity.
Right, and you'll notice within each of the activities there is a range. Certainly with younger students, you want to tighten it up a little bit, maybe put more tools out there that are obvious. But it surprised me when I saw Bill started to use one of the sticks as a carving tool, what he did with that. And had I predetermined by cutting the styrofoam or putting scissors out, or even with an older group a knife, he may not have had the same instinct of what to do with that tool, to carve it out and set the walls of his house into it. And I think that's a marvelous thing. Someone may ask for a pair of scissors eventually, and we may have to come up with that, but it's good to let them just play with the materials and explore for a little while.
Another thing I thought that was really good is the fact that you didn't put out enough objects for both groups to use. We can't look at what they're doing and copy it. There was only one piece of styrofoam, so whoever got it first, the other group could not use it.
Limiting, and I think sometimes our impulse is to have it so that everyone could do something. And I think if you limit resources, limit materials, it is challenging the group to come up with another answer, which is, again, part of designing under constraints. One of the comments that I was hearing up here is, where would this house be situated? Is it California? Is it the Midwest? This is Georgia. And a teacher could easily constrain this more and make it for a locality that if it was an arid, dry, warm climate, what differences might be in the design of that house.
If you had several groups, you could do different environment relations and assign them.
And if that's part of your curriculum, to explore several different environments.
Yes, I'm interested in the concept. How are you going to tie in the concept of earthquakes, or the dynamic earth with this project or activity?
One of the things you want to do right away with the class is prepare them with the science concept. Since we're dealing with adults here, we didn't feel that necessity. But with children, having started a unit on Earth, plate tectonics, the plates of the Earth, natural disasters such as earthquakes, a good thing to do is to give them a basis. What happens in an earthquake? What nations have earthquakes? What do they do to prevent them? Then, after this, you want to continue on with that discussion during the simulated earthquake. What is an earthquake? And certainly, duration and intensity are the two key features of an earthquake, and you want them to plan for that as they plan for their earthquake. A little bit of ignorance is fun here. If they knew everything about earthquakes, they're going to build more successful houses. And kids will learn a lot from failure in this activity. As a matter of fact, one group will almost be cheering that another group's collapses so that they can actually see a house collapse during an earthquake, but they don't want theirs to break.
I noticed a key phrase that we keep coming back to is groups. I think one of the big values of National Science and Technology Week projects is that they focus on cooperative grouping and cooperative learning. This could be done with a group as large as 4 or 5, could it not?
Correct.
Through various stages of research, preparation, and planning into actual implementation.
And depending on how used the class or the group of youngsters is that does this activity and how used they are to coming to consensus and the dynamics of the group process, the more that could be involved in it. I have personally done this activity with up to 5 students in a group. I don't like even numbers, particularly in groups. 3 and 5 are kind of my favorite numbers for the size of groups. And you want to make them come to consensus. And I'm particularly aware in groups of is one person dominating with their idea. And a reality of the classroom today is that girls often get outshouted, outmaneuvered, or overwhelmed by boys. And you want to construct groups, and you want to construct a fairness about those groups so that consensus can be reached. But the group dynamics is vital to these activities. As a matter of fact, I don't think I would do any of the activities as an individual, particularly because there is so much authentic feeling when you work together as a group.
Would you vary the materials according to the age?
Yes. I think that certainly with 4th graders, when I have done this activity, I tend to use more food products. Kids tend to connect with the use of them better. And it's almost more creative because they're so used to seeing lasagna noodles as lasagna, that to have to build with them is a real shift in their thinking. And you want to make them shift a little bit and problem solve.
Chuck, besides the obvious, I think there are also some real nice connections that can be made in the social studies, multicultural events, materials that are available in some parts of the world and not in others, and even literature.
Exactly. There's some nice books on the market about houses. There's one in particular called This House is Made of Mud. And would that be a good house to build in Southern California? There are resources available in most states from the Geological Society about earthquakes that may be prevalent in a region of the United States. And you may want to check with them to find out what earthquake preparation is available. Is there any in your district? Is there any in your state? Notice we haven't yet mentioned the scientific process. Even when we start to create a fair test, we're not going to pull out the flip chart and say, what is your hypothesis? Applying the scientific process in context is so much more valuable than talking about it out of context.
I was also interested in integrating a lot of the writing skills, like the journal, in with this and making the scientific process reflection. What was your hypothesis? How did you test that hypothesis? And as we go into the earthquake itself, it is a beautiful avenue for talking about the two different kinds of earthquake waves, as we will simulate a primary wave with the back and forth motion as opposed to the secondary or rolling wave of the earthquake.
Right. We've marked a table now for our earthquake simulation. I have taken about 5 inches on either side of the tray. The kids, what you want them to do at this point is to decide how much is going to be a big earthquake, how much is going to be a moderate earthquake, and a small earthquake. And you want to start with small earthquakes with kids because there's less likelihood that their house will be destroyed on the first round. In this case, the 2 pieces of masking tape mark the parameters of which you're going to create the movement. And as you can see, this is a pretty large movement. If that house in the tray that it's on is going to move that distance, that's going to be a pretty extreme earthquake. Because I knew these houses were so well built, we just went right to the big earthquakes. We're also going to need to time, and Bill, I see you have a watch there. The duration of this is going to be 15 seconds, which is a fairly long earthquake. This is a heavy-duty one. What I'm going to ask you to do now, with kids, you want to have one person basically doing the same backward and forward movement for all of the houses involved. You tend not to want to do it yourself as a teacher, because you want to be standing by to make comments, and you don't want to get blamed for breaking the comment. So, could I ask you, Melissa, to start here, and when Bill says go, to move it back as far as this piece and forward as far as that piece of tape. And we want to do this rapidly. We don't want to just do it at a slow pace. We want to move fairly rapidly from point to point.
Okay. Okay, stop.
Okay. Fairly typical of what happens to houses is that the roof does come off. But in this case, well, we did lose a side, I guess. Roofs tend to collapse or slide off houses, and talking to kids about why that happens. And talking to the kids, now realistically, graham crackers aren't used to build houses. What material is graham cracker most like that you do build a house with? And getting kids to explore that mentally as to what is this really like. And I try to be as consistent about that movement and the speed, even though this is your house.
Okay. Good.
Firmly attached to the base. Now, we can look at this now. If we were to do the next step, wonder if we put a second level on this. Would there be as much success with the second level? And that the higher you go, obviously you lose some of the safety features that the practical low house like this provides. And could every house in Los Angeles look like this? Would there be enough houses for people? And questions like that can occur naturally.